How to choose right adsorbents for gas separation? For the adsorption separation of gas mixtures, the equilibrium adsorption capacity of gas components, and the separation coefficient between them, are the two main indicators for evaluating and selecting adsorbents. Generally speaking, the equilibrium adsorption capacity determines the amount of adsorbent used. And the separation coefficient affects the separation effect between gases, which is finally reflected product gas purity and recovery rate. The larger the separation coefficient alpha, the higher the product gas purity and recovery rate. The separation performance of commonly used adsorbents for different gas mixtures is shown in Table 1:1 and Table 1:2. For mixture of nitrogen and hydrogen, the separation coefficient is 7.48 on activated carbon, which is smaller than that of 22.15 on 5A molecular sieve. And the equilibrium adsorption amount of nitrogen on 5A molecular sieve is 8.64 milliliters per gram, which is much larger than that of 4.49 milliliters per gram on activated carbon, so 5A molecular sieve is usually chosen as the adsorbent for the separation of gas mixture of nitrogen and hydrogen. For carbon monoxide and hydrogen mixture, although the separation coefficient of activated alumina and silica gel are 5.56 and 7.07 respectively, the adsorption capacity of carbon monoxide is too small, only half a milliliter per gram and 1.91 milliliters per gram, which is not suitable for the separation of carbon monoxide and hydrogen mixture. While the separation coefficient of 5A molecular sieve and activated carbon are more than 10, and the equilibrium adsorption capacity of carbon monoxide on molecular sieve is more than 3 times that of activated carbon, and it reaches 23 milliliters per gram, so the adsorbent of 5A molecular sieve is generally used for carbon monoxide and hydrogen gas mixture separation. For methane and hydrogen gas mixture, when selecting the adsorbent, considering that activated carbon has the largest equilibrium adsorption capacity and separation coefficient for methane, then 5A molecular sieve, silica gel and activated alumina. It is generally considered that activated carbon is more suitable for the separation of methane and hydrogen. In conclusion, for gas mixture of nitrogen and hydrogen, carbon monoxide and hydrogen, methane and hydrogen, the separation coefficient is greater than 20 for 5A molecular sieve, as well as activated carbon, indicating that the effective separation and purification of hydrogen can be achieved by using 5A molecular sieve or activated carbon. For mixture of carbon monoxide and methane, carbon monoxide and nitrogen, the separation coefficients between the components are less than 3 for all 4 adsorbents in Table 1:2, indicating that these commonly used adsorbents are difficult to achieve the effective separation of these gas mixtures. For carbon monoxide and methane, carbon monoxide and nitrogen mixtures, it is generally necessary to use a copper-loaded adsorbent, where copper and carbon monoxide can form complex bonds and effectively adsorb carbon monoxide to improve the selectivity of carbon monoxide adsorption. For methane and nitrogen mixture, the separation coefficient of 5A molecular sieve and activated carbon are 1.50 and 3.12, respectively. And the equilibrium adsorption capacities of methane are 12.94 milliliters per gram and 14.01 milliliters per gram, respectively. And the significant differences between them are mainly reflected in the separation coefficients. So activated carbon is more suitable for the separation of methane and nitrogen mixture. However, the activated carbon bulk density is smaller, and the volume of the adsorption tower will be larger. Thanks for watching. Please click the below link to find more information.